So when talking about angles of triangles, we know some important facts about all triangles. The first is that the sum of the interior angles, A plus B plus C, the angles inside of a triangle, always add up to 180. But what is the relationship between the interior angles and this exterior angle? Well, there was an activity in your workbook, activity 3, exploring an exterior angle of a triangle, that asked you to draw a triangle, label its interior angles, and one exterior angle. And what you were asked to do was take this triangle and cut out and I'm actually going to cut it with a little bit of an angle because I want to be sure that I know which is the angle A and which is just my cut piece. So there's angle A. If I didn't have cardstock, I would be tearing these. And angle B. So now I have angle B and angle A outside of that triangle. And what you should have noticed when you did that activity is that if you take A and B and you place them into this exterior angle, whoops, if I add them together, if I put them together, my hands are so dry. I put B there and I turn A around and I slide it right in there. You can see that A and B together, meaning we add them, are the same as that exterior angle D. A and B together make that exterior angle. Now notice I used the two angles that were not right next to D, not the adjacent angle, but the other two interior angles. So let's go ahead and add those two pieces of information to our notebook. First of all, the sum of the interior angles of a triangle, meaning the angles inside added together, is 180 degrees. X plus Y plus Z is 180 degrees. If I take all three inside angles, add them up, I get 180. That works with any kind of triangle. What you should have discovered about the exterior angles is that when you take the two non-adjacent, meaning the two not next to the exterior angle, and add them together, they're the same as that exterior angle. That was the example I just showed you. I took the two that were not next to D, and together they make up that exterior angle. So exterior angles are equal to the sum of the two non-adjacent interior angles, equal to the two non-adjacent angles added together. Now I proved it to you one way. I can also prove it to you another way using these two rules. I don't have a ruler handy, so I'm going to use my pencil box. And I'm just going to draw a triangle. Nothing special about this triangle. And I'm going to extend one of those side lengths. I'm actually just going to extend this one down here. So you can see I have angles A, B, C, and D. 3 interior angles and an exterior angle. Now let's assume that angle A was 44 degrees. And let's assume that angle B was, oh, I don't know, 48 degrees. I just made those up. I did not measure this triangle. But if I assume that A is 44 degrees and B is 48 degrees, do I have enough information to find C? Well, sure. I know that A plus B plus C should equal 180. 44 plus 48 plus C equals 180. All three of these angles together are 180 degrees. If I combine my like terms, 44 and 48, I get 92 plus C equals 180. Subtract 92 from both sides. C equals 88 degrees. So now I know all three of the angles inside of my triangle, all three of the interior angles. 44, 48, and 88. And that equals 180 degrees altogether. Now if I look at this triangle, I notice that there's a special relationship between angle C and angle D. Together, they're making this straight line, and I know that all straight angles have a sum of 180 degrees. So I know that C and D together should be 180 degrees. They make a straight line. We just found out, using what we know about the interior angles of triangles, that C was 88. So 88 plus something is going to be 180 degrees. If I subtract 88 from both sides, D is 92 degrees. That exterior angle is 92 degrees. Now 92 should ring a bell. That should be a familiar number to you. Remember when I took the two non-adjacent angles, the two interior angles that were not next to that exterior angle? If I added them together, they were the same. Let's see if that's true for this triangle as well. If I take the two non-adjacent interior angles and add them together, 44 plus 48, do I get that exterior angle? I do. So if you're given two interior angles, you can find the third and then use the fact that it's supplementary to find that outside angle, that exterior angle. Or you can use the theory that the two non-adjacent interior angles added together give you that exterior angle. Let's try some practice on the left-hand side of your notebook. The first example, and I'm just going to sketch these triangles. They don't have to be perfect. I know the angles may not seem realistic, and that's okay. It's just for the sake of an example. For this triangle, I'm going to tell you that this interior angle is 30. This interior angle is 40. And I want you to find the exterior angle Y. Now I have two choices. I can find the missing interior angle and then use the rule about supplementary angles to find Y. Or I can use the fact that the two non-adjacent interior angles added together will give me that exterior angle. The exterior angle is equal to the two non-adjacent, the two that are not next to it, added together. So in this case, y is 70 degrees. Sometimes it won't be this straightforward, and you'll need to do some solving of an equation to get to your answer. For example, I'll do this one in blue. If I have the triangle again, it's not a perfect triangle, it's just a sketch for the sake of the example. The exterior angle is 2A. This interior angle is 80. And this angle down here will be A minus 5. So going back to our rule about exterior angles, an exterior angle is equal to the two non-adjacent interior angles added together. So just like up here, y equals 30 plus 40. The exterior angle is going to be equal to the two non-adjacent angles added together. The exterior angle is equal to the two non-adjacent interior angles added together. 2A equals 80 plus A minus, excuse me, A minus 5. I don't need to keep the parentheses any longer. This is just letting me know that that entire angle is A minus 5. If you keep the parentheses, you might think that there's some distributing that has to happen, and there's not. It's just addition. I'm going to start by combining like terms. I see that I have an 80 and a minus 5. 80 minus 5 is 75. So on this side I have 75 and A. And on this side I have 2A. I want to get all of my variables together. So I'm going to remove the A from this side. 2A minus A is A. A is 75. I haven't yet found the exterior angle yet. Don't forget the exterior angle was 2A. 2A means 2 times whatever you found A to be, which in this case is 75. So 2A is 150. So this exterior angle would be 150.